Let us do problems on source transformation technique. First question, important question is find the power delivered by 50 volt source in the network shown in figure. This is the diagram. So in this figure, you have to find out what is the power delivered by this 50 volt source. Okay. So don't while doing source transformation technique, don't touch this. You have to keep as it is because we want to find power delivered by 50 volt source. Don't transform this. So you retain this portion as it is. So remaining this and all we can reduce. Okay. First I'm applying. I want to reduce this circuit. See, observe here. This and this full is one node. This is actually separate node, and this full line is actually single node. Okay. And between this and this node we have one 2 ohm, and here is a practical voltage source 10 ohm 10 volts with internal resistance of 3 ohm. So we have to reduce this one to single. You can convert this voltage source into current source. I am converting this voltage source into current source. I am not touching this because I want to find the power delivered by 50 volts. So I am converting this right side voltage source into current source because I have to reduce single resistance. Okay. So if I convert this, we know that the formula for conversion, the formula for conversion is uh, you can convert this voltage source into current source by V is equal to IR. So I is equal to V by R. So I is equal to, we can write I is equal to, this I is equal to 10 by 3. Okay, this is voltage, this is R. So I is equal to V by R. So this 3.3 is how means it is 10 divided by 3. So 10 divided by 3 is 3.33, and always the arrow mark is towards plus. Okay, in the battery, you see here this is plus, this is minus. So arrow mark you have to write like this in the current source. Okay, so current source you have to write upwards, and the same 3 ohm you have to write parallel now. For always, for a current source you have to write parallel resistance. For a voltage source you have to write series. Okay, we are converting source transformation. We are transforming voltage source into current source. The value of I is equal to voltage by resistance, that is 10 by 3 here. So it is 3.33. Arrow mark is important. Wherever it is always towards the plus. Arrow mark is towards plus, minus to plus, no, like this. So I'm writing arrow mark at the top here because here plus is at top here, and same 3 ohm you have to connect parallel. So now this don't get confusion here. This 10 amps and 2 ohms are connected vertical because I told this entire thing is single node. This entire thing is single node. So you can write instead of slanting here, you can convert into vertical. 10 amps going upwards and 2 ohms connected parallel. So this is, we are rewriting this 10 amps and 2 ohms. This is a current source 10 amps with internal resistance 2 ohm you can consider. So and we are writing original like this, and to add these two we converted this practical voltage source into current source. We converted this practical voltage into current source. What is the advantage means, we already know that in parallel currents can be added, in series voltage can be added. Now between this node, okay, between this node and this full line is one node, this full line is one node, top and bottom also this full line is one node, and currents, two currents are going upwards. 10 amps is going upwards, 3.3 is going upwards. So in parallel between two nodes, two currents are going up means we can add it. The direction of the current is same, it is going towards the node, it is also going towards this top node. So both will be added. So 10 plus 3 is, we are getting 13.33. Next we have to find out between same two nodes, two resistors are in parallel. These 2 ohm and 3 ohms are in parallel. So 2 into 3 divided by 2 plus 3. Okay. 2 into 3 parallel combination. 6 by 5. 6 by 5 is you are going to get 1.2 ohms. So what is the need of conversion? This one is there is a voltage source and there is a current source. Okay, and you need to convert this voltage source into current source, so that you will get one more current and the resistance here parallel. Same resistance you have to connect. Resistance value will not change. Same resistance you are connected parallel, and in parallel currents can be added, and both the currents 10 amps and 3.33 both are going upwards, so both will get added. If they are going opposite direction, you have to subtract according to that. Okay, so it is 13.33, and instead of two resistance 2 and 3, they are parallel resistance. Okay, 2 and 2 is parallel with 3, so 2 into 3 divided by 2 plus 3 is give you 1.2. So now we have to find out power delivered by 50 amp 50 volt source. So again we need to convert this current source into voltage source. We can consider this 13.33 in parallel with 1.2 as a current source. We can transform once again this current source into voltage source, so that you will get one voltage source. So what is the value of voltage? Voltage value is V is equal to IR. I is 13.33 and R is 1.2. 13.33 into 1.22 will give you 16, and the 16 is V is equal to IR. Okay, V is equal to I into R. So I is 13.33, R is 1.22, approximately you're going to get 15.99 something. It is approximated to 16 volts, and same 1.2 you have to connect in series, because always for a current source resistance is connected parallel. For voltage source you have to connect in series. So now we got a simple circuit, okay, simple closed loop circuit. So in this we have left side 50 volts, right side 16 volts, because this is converted into this current source. This current source is converted into voltage source. Now we have to find current. What is the current here? Potential difference you take. Potential difference is here 50 volts is there, here 16 volt is there. Always current flows from higher potential to lower potential. So that is the current will flow from 50 volts to 16 volts. Okay. So 50 volts is our left side voltage. This is the right side 16. So potential difference is 50 minus 16 divided by total resistance in the loop. Total resistance is 5 plus 1.2. So 50 minus 16 divided by 5 plus 1.5 plus 1.2, that is 6.2, will give you 5.48. That is the current. So if you want, you can apply uh, KVL also. You can write minus here, this is plus, and current flows from plus to minus here. This is plus to minus. And if you write minus 50, okay, if you write KVL, minus 50 plus 5i1 plus 5i plus 1.2i plus 16 is equal to 0. And if you simplify, you'll get the same expression. And once you know the current in this closed circuit, so we know that power delivered by voltage source is given by P is equal to actually V into I. Power is given by V into I. V is 50, I is 5.48. So power is given by V into I. So in this problem, we got 50 into 5.48 as 274 watts. So it's the important problem. Find power by delivered by 50 volts. Or similarly, same problem if they ask find power delivered by 10 volts. Find power delivered by 10 volts. Then you have to retain this 10 volts and 3 ohm as it is. Now you have to do conversion from this side. So you can convert 50 in series with 5 ohms. This one into current source. Then same procedure what you did know here. Same procedure you have to do, and you will get once again same type, similar type of the circuit here. You'll get same type like this. After that, once you find the current here, we'll get the same 5.48. After that, power delivered by 10 volts will give you in that reduced circuit whatever current is coming, that multiplied by 10 volts, that will give the power delivered by 10 volts source. So here power delivered by 50 volt source, that's why this is you have to keep as it is still. See here 50 volts till the last stage, 50 volt is not transformed. Okay, only 10 volts is transformed. Again, this 10 and this 3.3 they are going to get added, and we got simple circuit, and we did not touch this 50 volt source. So this is how to find power delivered by 50 volts source. Thank you.